Saxon Algebra 2, Lesson 64. This is a lesson that's going to make you feel smart. The first topic is complex fractions, and the second one is complex numbers. How about that? Everything is so complex, but you've got it. Complex fractions, as you well know, is any fraction that has more than one division bar in it. And we've been working on these for quite a while. We're just making them harder every time we do them. Isn't that just so cute? Remember that the basic idea, let me write it first. The basic notion here, in the immortal words of Evie Jones, I hope you guys know Evie. Her family was a part of all of these homeschool groups that have developed. She and her sister Esther and their brother Alice are cousins with the Rices, Vivian and Laura, which blew my mind when I found that out. But Evie used to call these smush and flip problems because we add fractions and then we use reciprocals to make them go away. So it's the smush and the flip. She was like, oh, the smush and flips, I love these. So that's what we're going to do. We're going to smush and flip. But the first thing that we always do is we go to the very bottom of the basement and start at the bottom, because remember, our goal is to turn denominators into ones. So that's why we go as low as we can, and then we'll work our way back up. All right, so this seems to be the lowest part. So the first thing we have to do is smush this, because we can't use the reciprocal unless it's a single fraction. So least common denominator is b, and what I like to do, I'm going to multiply this by b over b and then combine them, right? But I want to do it with as little writing as possible. So what I do is I write the b there, then I make the fraction line go like that. Now it's like I've added them together, right? Because it was going to be b times x over b, and then I was going to add it to the 1 over b. But now I've accomplished that with a lot less messy scribbling and writing. Now I can multiply by the reciprocal, which is b over 1 plus bx. Okay. And before I do anything more, I'm going to go up here. This all cancels. Hallelujah. I've got a 1 up here, and remember the 1 is like the numerator, and I'm going to multiply that by that. And then I can put a denominator in it, and I'll multiply that by that. Now, beautifully, those are 1s, so I've got no drama there. So I'm going to rewrite this, because I've got this a to deal with. A plus, and then I've multiplied that, b over 1 plus bx. Oh, so quickly, we've cut the drama, right? So now all I have to do is get him with that same denominator, and I'll be good, right? So what I'm going to do is I'm going to write it over here. Obviously, I have to multiply a by that whole thing. And now I can just extend this line, right? Because they both have the same denominator. And now I can rewrite this. I'm going to distribute this. Sometimes John distributes, sometimes he doesn't. I kind of like to distribute in the top because you might find some like terms that you can combine with what's over here. Not always, but sometimes I like to distribute the top, but not necessarily the bottom. A plus abx plus b, that's the b just chilling, all over 1 plus bx. Is that our final answer? Yay! That's it. Do you feel smart? You should. These are hard. Okay, we just have one more of these. Example 64.2. It looks a little different at the beginning, but it's okay. Okay, we're going to use the same strategy as last time. Because last time what we did was we ignored that a, we fixed this up until it was just a single fraction, then we put them together. That's what we'll do this time. We'll fix all of this side, and then we'll add it to the a over x. Down here is where we start. We have to make the denominators match. He is going to need an x underneath, so we're going to have to multiply an x on the top. So it will become x over x plus b over x, and I'm going to write that like that. Now I've smushed them. Now I can flip. And I like to write them at the very same time before I get all excited about doing that. I don't want to mess up the top. The 4 is being multiplied by the 8, and we can think of it as being over 1, and the 1 is multiplied by that thing on the bottom. All right, let's rewrite at this point a over x plus 4x over x plus b. That looks a lot less menacing, doesn't it? We're making progress. Now our drama is that we have to make these guys match, and there's no way to just add a plus b to that, right? The only way we can do it, again, this is why I like to refer to it as a least common multiple rather than a least common denominator. This name reminds us that the only way to get a least common whatever you want to call it is to multiply. We have to multiply to do it. So that means this one we're going to have to multiply by x, right? Because we need to, the bottom has to end up being, here, I'm going to write it out this time a little bit more. This will be x plus b times x plus b. I've been shortcutting how I show you that, but I want to show you this more distinctly because this least common multiple is a little bit crazier. All right, so that's what I'm doing. So now that's going to turn into, I'm going to distribute on top, ax plus ab plus 4x squared, and that's all over x times the quantity x plus b. Is that the right answer? You don't know. Well, I mean, you could, but your book's not in front of you. I'm going to rely on John. Ax plus ab plus 4x squared plus over x times the quantity x plus b. Yay! Okay, so that's our new step forward into complex fractions. I can never remember exactly where we were, but this is making it a little bit harder. We've got the smush and the flip, and we're having to combine wonky fractions together. All right, part B, complex numbers. We have 1, 2, 3, 4 problems there. You're writing all this down, right? Complex numbers, sorry. I was going to write complex fractions again. I guess I wanted to do all those problems over. I did enjoy them. Okay. Here is the thing. We're going into complex numbers. You guys know how to do this. We know that when we have a negative sign inside of a radical that is even numbered, this one's 2, that's impossible. And so what we do is we basically pull out the -1 and call it I, right? We say that I is equal to the square root of -1, right? So if we want to, we can think of this as square root of 2 times the square root of -1, and then this is what turns into an I, right? We can break it down that way. And then we know that for every pair of i's, that's a -1, right? Those are our facts. We also know that when you have an imaginary number, often there's an imaginary part and a real part. We call that a complex number. Where the A is the real, whoop, and the B part is the imaginary. Which makes sense because that's the part that's chilling with the I. All right, we know all of this. We like this format for complex numbers where we have the A plus the BI. So let's try applying some of this. 64.3. We have square root of minus 2 times square root of minus 3. One of the first points John wants to make is don't mess around with trying to figure out if these two minuses make a positive. Don't do any of that. The first thing we do when we have a negative number is rewrite it into this form. So I'm going to immediately rewrite this as square root of 2i times square root of 3i. Then I can combine the two pigs, square root of 6 times I squared. Now this can jump over here, and our final answer is minus square root of 6. Okay, so the cautionary tale here is once you see those minus signs, immediately rewrite into this notation and then go from there. Okay. 64.4 is one of those long trains. All right, I'm going to scoot this up a little bit so you can see even better. All right, every two i's makes a negative 1. So we can take two of these i's, pull them out. There's the negative 1. There's one I left. This turns into two negative 1s. So when we multiply all three of these negatives together, it's going to stay negative, isn't it? But I've burned off all of the imaginary parts. So now that turned back into a real number, didn't it? I'm getting choked up. I'm emotional about this. Grace, no. Grace is having a hard time because we're in a room with a closed door and she can hear my daughters in the kitchen. They're baking chocolate chip cookies and lemon squares. And she really wants to go in there. Not that they're going to feed her, but, you know, she's a dreamer. Good girl. And so she really wants me to open the door, and I'm refusing to do so. Good girl. Can you hear her tail knocking on the bookcase? Good pickle. Good Sue. Good girl. You have to be quiet. I just found a stick in her fur. Oh, it's never ending. Okay, now we're here. This is a problem, so we immediately rewrite this as square root of 9 times I. That's just a single I, so we can't do anything with it. That's going to stay. But this we can turn into a 3, can't we? So this is going to become plus 6I. Woo! Going through the changes here. And then this becomes square root of 3 times square root of 3, and each of those guys has an I, right? So now, square root of 3 times square root of 3, that's a pair of pigs, so we can jump that out as a single 3. But these two i's make it a negative. So I'll write it like that, because I already wrote the plus sign down, which is fine. Okay, so now what I can do, I've simplified all of these beautifully. Now I just want to rewrite into this format. So I look for the whole number, or the real parts first. That's a total of minus 5. And then the imaginary parts gives me plus 2i. Is that right? Yay. Final answer. Huh. Those are kind of long and tedious, but not too hard, I hope. As long as you remember these rules, you're good to go. All right, we have 2 more problems. Ready? Multiply. Oh, aren't we getting fancy? We're supposed to multiply two complex numbers. Notice they're written in that A plus BI format. I'm going to write our other two square root of minus 1 equals I, and I squared equals regular minus 1. Here's our puffy clouds of relevant knowledge, just floating up there in the sky. I'll keep them handy. This, we see they're in this format, so that's cool. But we also notice they're just binomials, really, if you think about it. So let's write them in a stacked format and multiply them by doing the dance, just like we always do when we multiply binomials. Ready? 4 times 3 is 12. 3 times 2i is 6i. So far, so good, right? Now she sits down, her turn, minus 8i. And now here's where it really gets fancy. I'll write it as long as possible, and then I'll show you shortcuts later. Minus 4i squared. Oh, okay. What this does is it turns into a minus 1, and that minus 1 turns this into a plus. Circle it to show that it's after the change. Now when I add, I can take this 4 and combine it with my 12 to get 16 minus 2i. That's straightforward. 16 minus 2i, that's the right answer. Make sense? Tricky, but we just use these rules and apply our usual rules of multiplying binomials. 64.6. This time, John is throwing us just a wee bit of a curveball. What he's doing this time is he's given this one in the proper format, but this one's messed up. And let's just say that you didn't catch it. That's fine. It's just absolutely fine. You can still multiply them even though they're in a wonky order, right? We'll just do it. 4 times 5i, 20i. Minus 8, sit down. Then this becomes plus 15i squared. And this becomes, I'll write that one over here, minus 6i. So what we see is that we're getting the same 4 products. We're just getting them in sort of a weird order, but it's okay. I combine the ones that I can see are going to look alike. So this becomes 14i. This is the one we have to clean up. This becomes a negative 1, so that changes this into a minus. And then minus 8 minus 15 is minus 23. And when I write my answer, I'm going to make sure it's in the proper format. Minus 23 plus 14i. Yay, that's the right answer. Make sense? If I were doing this problem and I remembered to flip this one around so it was in the proper format, I like that better. It just seems a little neater and more organized, but what I wanted you to see is that even if it's messed up, you're fine. It'll work out just fine. It just looks a little weird. All right, we're done. Please sit right now and pat yourself on the back. All 3 of you, I'm serious. I hope you're together right now. Pat yourselves on the back. I just patted myself on the back. Because this is a very sophisticated lesson. And as far as I can tell, you handled it just fine. So, that is the end of 64. Congratulations. I will talk to you soon on the video chats. If you did not talk to me last week, I think it's just Micah. I think I talked to Abby and Kyle both. But make sure that you remind me to have you catch up on any review problems that you may have missed last week. Thank you. Farewell, goodbye.